So yesterday we talked about definitions, okay? And the reason we talked about definitions is because they're the building block for all our other content. And we need to be able to have that dialogue with one another. So you need to know what I'm talking about. I need to know what you're talking about. You've always heard the phrase, say what you mean what you say, right? Okay, you've never heard that before? That's the idea. I get a lot of people who have conversation and they'll say, oh, well, you know what I mean. But they might have used a word that doesn't match with what they really mean. Does that make sense? And in mathematics, that can be very problematic. Okay, so we in this first couple chapters, we'll talk a lot about structure of statements, types of statements, and that kind of thing. So yesterday's definitions. Today, we're going to talk about things called biconditional. Okay, we've already talked about a conditional statement. A conditional statement was an if-then statement, right? Okay, when I put the prefix of by on something, what does that mean? It means two. Okay, so when I say biconditional, what that really means is I've got two conditional statements being provided to me in one statement. Okay, so biconditional, by its definition, is a single true statement that combines a true conditional and its true converse. Okay, so a biconditional is, I can't just say it's two conditionals, okay, because remember we were talking about conditionals the other day. We could have an inverse, a converse, and a contrapositive, right? So if I just say it's just two conditionals, it doesn't narrow down to what we really are interested in, okay? So it's two conditionals, but one of them is a conditional and the other one is its true converse, okay? And both statements are both true, okay? So biconditionals are written by joining the two parts of each conditional with the phrase if and only if. If and only if, okay? And this is structure that we need to talk about as we move through this course. I wish I would have known this or paid, I guess I didn't pay attention when I was in high school in geometry the first couple months, and they talked about this because what ended up happening is I go on to higher level math. I go to college, take a bunch of math classes, and this if and only if, I would just read that and I would just make for some reason somebody just, instead of writing if, they got a little excited and wrote if and only if. But I viewed it as it was just the word if. Does that make sense? And that got me in trouble with things because what it really tells me when I say if and only if, it really tells me that the phrase that I'm reading, I can read it the way that it's presented, left to right, and it be true. But when it says if and only if, that is a certain structure, a certain notation that tells me you can actually reverse the phrase, read it backwards, and it still be true. Does that make sense? I said the other day in mathematics, people want to, when they learn a procedure, they want to always reverse it and say, well, if I can do it forwards, I should be able to do it backwards. You can't with most things. In mathematics, the only things that you can do that with, they will give you notice with the phrase if and only if. Okay? And when you see that, that means you can apply the rule forward and backwards or in reverse. Okay? So if we look at this, so what is the converse of the following true conditional? And it says if the converse is also true, rewrite the statements as a biconditional. Okay. So here we've got in this blue box, it says if the sum of the measures of two angles is 180, then the two angles are supplementary. Okay? If the sum of the measures of two angles is 180, then the two angles are supplementary. Would you guys agree, or what do you think about the truth of that? Is that true or false based on what we know? That is true. Good. Okay. That is a fact that we talked about a couple days ago. Can't spell true. All right. So that is true. So then it wants us to write the converse of it. Do you remember how we construct the converse? You remember this part here being called the hypothesis. Okay? And this green part is called the conclusion. Do you remember what we do with those two things to create the converse? we switch them, right? We flip them, okay? So change their positions. So it's just easier for me to type this. And let's go, if two angles are supplementary, then the sum of the measures is 180. Okay, so when you guys know what it means for things to be verbatim? What's verbatim mean? Word for word. Okay. When you flip these and rewrite them, they don't have to be word for word, but they have to be concept for concept. And if you leave words out, make sure that you don't leave words out, or you restructure it to where it brings in extra meaning or leaves out a particular meaning. Does that make sense? Okay. But it says if two angles are supplementary, then the sum of the measures is 180. What do you guys think about that truth value? Is that true or false? If they're supplementary, then their sum is 180. That's true, right? Okay. So what we've got here is we've got a conditional that is true. We have its converse that is also true. So because it's a conditional, it's converse, they're both true. These statements can actually be rewritten as a biconditional. So I'm going to write the biconditional down here for us. And there's two ways you can write every biconditional. Because you can read them forwards and backwards, okay? Basically, all you're going to do is you're going to take one of those statements that is up there, whether it be the conditional or the converse. Doesn't matter which one. I'll do both, but it doesn't matter which one. You get rid of the word if, okay? So I'm just going to take the one that we started with, the one that was highlighted blue. I'm just going to get rid of the word if, and we'll start with the word the sum of the measures of two angles is 180, okay? Now you're also going to get rid of the word then, but you're going to replace the word then with our phrase if and only if, okay? So if and only if, and then once you have that, you finish off the phrase. It says the two angles are supplementary. And what that means to us is I can read this. That's one version of my biconditional. Says I can read it as the sum of the measures of two angles is 180 if and only if two angles are supplementary. I can read it left to right and I gain information from it. But I can also read it right to left. Now, when I read it right to left, I'm not going to be a moron about it and say supplements are angles to the if, only, and if 180. Does that make sense? When I read it right to left, I'm going to say the phrase on the right says if the two angles are supplementary. So that's what I'm going to start with. The two angles are supplementary, then the sum of the measures of the two angles is 180. So, okay? So it's a reversible phrase. If you wanted to write the biconditional using this statement here, okay, it would look like, let's see here. We would take the word if out and we write two angles are supplementary if and only if the sum of measures is 180. And that right there kind of shows you the reverse of writing this first one. That make sense to everybody? Okay. So those two things are acceptable versions of our biconditional. All right. What is that phrase actually the phrase for? What is that statement? What kind of statement are we talking about there for supplementary angles? It's the what for supplementary angles? Not the postulate. It's something like that. We talked the other day, we talked about postulates. We said there's postulates, there's theorems, there's corollaries, there's lemmas, and there's definitions, okay? So that is the definition of supplementary angles. And something that is key for us to know is that every good definition can be rewritten as a biconditional. And think about this. And you guys have done this on tests and quizzes. You guys, is your sparkle thing that you're talking about, is that a vocabulary thing for like definition, spelling, stuff like that? Okay. So you do this in your English classes where your teacher can give you the actual definition, and then you match it to the word that it goes to, right? But you also have questions where they give you the word, and then you've got to write out the definition, correct? Okay. Well, what that is that's the idea of a biconditional. Okay, that's reversible, right? I can give you the word, you give me the definition. Or I can give you the definition, and you provide me the word. Does that make sense? Okay, so that's the structure or the logic of a biconditional, and the fact that it's reversible. So every definition we come across is a biconditional. Okay, our phrases for if and only if, we saw it above. When it's in print, what you're going to see is a lot of times the author doesn't like to write if and only if, so they will write like a italicized IFF, okay, and that stands for if and only if, okay. Again, something I didn't pay attention to when I was in high school, and I thought somebody just had a typo, just left their finger on the F key for too long, and I just read it as if, okay. So make sure that we understand that notation tells me I can go both directions with reading and understanding, interpreting the statement, okay? The symbols that we use, okay? So the other day we were saying P, and then we had our arrow, and then we had Q. And the way we read that was if P then Q, or we said P implies Q, meaning if P is happening in front of you, then you can make the conclusion that Q kind of is true as well for that situation. Now, we put a double arrow on there, and it tells me basically it's a two-way street. We can say P implies Q, but Q also implies P. Does that make sense? Okay, you can start on either end, and so that's the notation of that double arrow, okay? An example here is another example that we see a lot. So the point is a midpoint if and only if it divides a segment into two congruent segments. If you think about it, that's the definition of a midpoint, so it makes sense that we can write it as an if and only if statement, okay, or a biconditional. Is it okay? All right. I want you guys to say, it says, what are the two conditional statements that form this biconditional? So what I want you guys to do just for a moment here on your own, and you'll see our success with this. Take this. This is a biconditional right now. I want you to take it and rewrite it as the two if-then statements that compose that biconditional, that create that biconditional. Okay. So write those, and then we'll come back together and talk about that in a moment. All right. I think just if I'm trying to kind of deconstruct a biconditional down to the two conditionals that made it, and I know I had some stuff there that told you let P be whatever and Q be whatever, but if I don't even pay attention to that, think about how we took two conditional statements and wrote one of them as a biconditional by taking the word if out and replacing the word then with if and only if, right? Well, taking a biconditional and breaking it down to two conditionals is the reverse of that. Okay, so I'm just going to start with the phrase that I have. Okay, it says a ray is an angle bisector if and only if it divides an angle into two congruent angles. So really what I'm going to do is take the phrase if and only if out, and then I'm going to add the word if at the beginning, and then where I took if and only if out, I'm going to write the word then. And now I've got one of the conditionals that made that biconditional. Does that make sense? So if a ray is an angle bisector, then it divides an angle into two congruent angles. That would be one of the statements that I was looking for you to write. The other one then, okay, what do we know about the two conditional statements that make the biconditional? One, they're both true, and they're converses of one another, right? Can we take that blue phrase I have highlighted and write if it divides an angle into two congruent angles, then a ray is an angle bisector. Does that make sense? I'm a person, so I think it's direct objects and that kind of thing. When you get into your grammar and all that stuff, that's confusing. Like when I read that, when I read a sentence, it says if it divides. I want to know, well, what is it? Does that make sense? So this is what I was talking about. It doesn't have to be like verbatim. I think I would probably, I know they're talking about array, okay? So I would probably rewrite that second conditional as if a ray divides an angle into two congruent angles, then it is an angle bisector. Does that make sense? Okay, I think it's important early on in your sentence to know what is your noun that we're talking about, instead of doing that at the end of the sentence. But if I do that, it doesn't change any concept. I don't add anything in. I don't remove anything that changes the meaning of my phrases. So is that necessary? Not really, but I think it's important. So this stuff later on in this section, these are all things that we talked about yesterday. The key things about a good definition, you want to use terms that are already commonly used or already understood or already defined for my audience. So if I'm writing a definition and I know that I have a 9th and 10th grade audience, I'm going to use words that I know 9th and 10th graders are accustomed to, right? Okay. You're going to hear me all year use words that you've probably never heard before, okay? And not math words. And I do that on purpose so that you guys can kind of get used to building a vocabulary, right? We used ambiguity the other day, right? Okay? A word probably you don't use all the time or you haven't heard very much. But I want you guys to kind of build your vocabulary. But for the most part, if I'm going to define terms, they have to be using other terms that we already understand. We have precision. Okay, you guys talk about precision inside science class, right? Okay, you talk about the tools that you use to measure something. I want to measure the distance between here or me and the board. Okay, I'm going to use some type of tape measure, right? The precision of the tape measure is, if it just has inches on it, I'm going to only be as precise to the nearest inch, right? Okay, so the distance might be 223.75 inches, but if I only have inches marked on my tape measure, I can only say that's 223 or 224 to the nearest inch, right? If it goes down to the nearest half inch, maybe now I'm a little bit more precise. Does that make sense to everybody? If I go down to a 16th of an inch or 32nd of an inch or whatever, we can be more precise with those measurements. So that's what we're talking about with precision. We talked about yesterday when I was close to Jager. I said I'm close to him now, and then I moved. I said I'm still close. Moved again, and now I said I'm far away. Well, close and far, they're not precise terms. Okay, things like large and sort of and almost. Those are bad words to see inside definitions because they lack precision. And it's also reversible. And because it's reversible, that means a good definition is a true biconditional. Okay. There are some other examples on here, okay, but I think you guys are going to be, the structure of a biconditional is to make sure that one, the original statement is true, then you can come up with a converse of it. Is it true? If they're both true, you can take them and write a biconditional by just taking one of the statements, delete if, delete then, and then put if and only if inside where then was, okay? And you've got your biconditional. Is that all right with everybody? Okay. Now, if you have a conditional that is true and its converse is false, you cannot create a biconditional, okay? And what I need you to understand is that in your textbook, as we progress through the year, and I say textbook, but essentially my notes that I give you, if it's written as an if-then statement, that phrase, until we're told otherwise, is not reversible. If it's told using the words if and only if, then you can use it forwards and backwards as you see fit. All right. There's a lot of stuff in this class. I don't like the way that they do it because they talk about biconditionals. They get us to structure it this way, and then like chapter 3, like section 2, will say in this chat or this section, we're going to talk about these if-then statements. And then in section 3.3, it talks about the converse of them. Well, if we think about what just happened there, then we could have actually merged section 3.2 and 3.3 into the same section, written them as biconditionals, and saved a lot of time and paper. Does that make sense? So every time we see a statement in the class, in any math class, it says if, then, that's the only way you can use it. Okay. There's an assignment in Math Excel, it's 2.3. It shouldn't take you very long. It's very similar to what you saw in like 2.2, a lot of reading, checking bubbles, that kind of thing. But again, shouldn't take you an immense amount of time. If you got questions on that, please don't hesitate to ask. Give you this time here to finish up all your kind of outstanding assignments that are there. I believe that 2.2, do I have that open till tonight? Okay, and then 2.3 will be due on Monday, but you should probably be able to get it done within the time that I've given you here. One thing to remember, and I've had several people do this, if I assign a homework assignment tonight, and then I give you time in class to do it, and then it's not due until Monday, if you're sick on Monday, it's still due for you. Does that make sense? If you're here the day that it's assigned, it's still due on the day that it's due, especially if I gave you time in class to work on it when you were here. Now, if there's like extenuating circumstances, special circumstances, maybe like a family emergency or something like that where you were here but you couldn't work on it at home, let me know those things and I can extend stuff for you. But probably 99% of the time, if you're absent the day it's due, because you're here the day it was given, it's going to be due for you the same time.